All right, let's jump right in. If you've ever wondered how massive, complex digital systems don't just collapse under their own weight, you are definitely in the right place. In this explainer, we're going to explore how building software isn't just chaotic typing, but a highly disciplined engineering journey. Our journey today covers 6 key stages. First, the software process, then frameworks for building, defining the rules, design and implementation, the testing phase, and finally, software evolution. Let's get to it. Starting off with Section 1, the software process, turning chaos into structure. So, what actually is a software process? Basically, it's the structured set of activities you need to develop a software system. The crucial point to remember here is that creating software is way closer to constructing a physical skyscraper than it is to playing around with digital clay. You absolutely need a baseline model, an abstract representation to give the whole project direction. And that gives us our baseline roadmap. It doesn't matter if you're building a tiny mobile game or a massive global banking system, every single piece of software universally goes through 4 distinct phases: specification, design, validation, and evolution. This coherent set of activities is literally the backbone of the entire engineering effort.
Moving right along to Section 2, frameworks for building, picking your process model.
Just like an architect picks a specific building method, software engineers use generic process models. And it's fascinating to look at the sharp contrast between 2 of the foundational ones. On one hand, you've got the classic waterfall model. This is super rigid, separate, distinct phases flowing downward from specification right into development. The catch? It's incredibly tough to change course once you've started. But flip the script and you have evolutionary development. Here, specification and development are totally interleaved. It's highly adaptable, you work right alongside the customer, and the system just sort of evolves from an initial outline. It's an absolute lifesaver when the requirements are a bit fuzzy right out of the gate. But wait, there are other tools in the toolkit. Engineers also use formal systems development. This is hardcore math, a rigorous transformation from specification straight to implementation, like the famous clean room approach, where mathematically proving the code is correct is paramount. Or, and we're seeing this a lot more lately, there's reuse-based development. Instead of reinventing the wheel, teams grab existing commercial off-the-shelf components, or COTS, tweak the requirements to fit, and snap everything together like giant digital Lego blocks. All right, Section 3, defining the rules, better known as software specification. This is where our chronological journey truly begins. And let me tell you, you absolutely cannot skip this. Before anyone writes a single line of code, teams have to run through this rigorous requirements engineering process. It's like a strict gateway. First, a feasibility study to see if it even makes sense. Then, elicitation and analysis to figure out what the user actually needs. After that, you draft the formal requirements specification, and finally, requirements validation to confirm it's rock solid. If you don't establish the right services and constraints here, you're just perfectly solving the wrong problem. Next up, Section 4, design and implementation. Time to bring those blueprints to life. With our rules locked in, we have to convert those specs into an actual executable program. Engineers dive into a deeply interwoven web of design activities. We're talking everything from overarching architectural design and abstract specifications, down to the nitty-gritty interface, component, data structure, and algorithm design. It's the whole shebang. They usually map all this out with systematic graphical models before they even start coding. And honestly, design and implementation are so tied together that these activities just constantly overlap. Now, here is a fact I find absolutely fascinating. Programming is a completely personal activity. There is no generic, one-size-fits-all programming process. Surprisingly, in a field that is so heavily engineered and structured, translating a precise design into code is still very much a human craft. It completely relies on individual logic and human problem solving. And hey, human beings make mistakes, right? So implementation naturally includes a structured debugging cycle. It's a constant loop. You locate the specific error, you design a targeted repair, you actually fix it, and then you rigorously retest the program. It's this essential, repeating, microscopic loop humming along inside the larger building process. Which brings us to Section 5, the testing phase, proving it actually works. Once the software is built, we hit validation to prove it conforms to those strict specs we laid out earlier. Think of testing like climbing a staircase. You start right at the bottom with unit testing, checking individual pieces. Step up to module testing for related collections of components. Then subsystem testing ensures those modules actually talk to each other properly. Near the top, system testing looks at the software as one giant whole to verify emergent properties.
And finally, the summit, acceptance testing, where you use real customer data to prove it's actually ready for the real world.
Finally, Section 6, Software Evolution, where the cycle continues.
You'd think launching the software is the finish line, right? No way. Software is inherently flexible, and it literally has to adapt to changing business circumstances, so the life cycle just loops back on itself. You assess the existing system, define new system requirements based on a shifting landscape, propose changes, and modify the whole thing. As the business evolves, the software has to evolve right alongside it.
And this quote from the source material absolutely hits the nail on the head. There has been a demarcation between development and evolution. This is increasingly irrelevant as fewer and fewer systems are completely new. The old-school wall separating creating software and maintaining software has practically vanished. Modern software engineering is basically just a continuous, never-ending state of modification.
So I'm going to leave you with this thought to chew on next time you open up your favorite app. Knowing all about this constant, invisible engineering lifecycle buzzing away right beneath your fingertips, is the software you use every single day ever truly finished? Thanks for exploring this explainer with me. Stay curious, keep learning, and I'll catch you on the next one.